Hello, good morning and welcome to this, the third of our series of webinars on managed cloud and the related technologies that term encompasses. Today we are going to be, if I just clear this part of my screen, today we're going to be talking about IoT and Big Data, two very hot industry buzzwords. And so just trying to advance to the next slide. Normal service will be resumed. So the next 30 minutes or so, actually we don't envisage it being that long, but it depends on the questions that come in. So we're going to be covering what is big data? What is this term that everyone's talking about, and why is it important to me? Where's that data coming from? How's it being used? I'm going to look at a case study which is very interesting, and it shows the first-hand application of big data and IoT working together, and then we'll go through a summary. I like to keep these things fairly interactive. You'll see that on your panel there will be a raise your hand for a question. So if you have a burning question while I'm going through this, please feel free to ask it. My name is Shoaib Usman. I'm the Sales and Marketing Director at JAR, and I'm very pleased to be talking with you all today. So let's get right into what is big data. As the name implies, one of those things, it's exactly what it says on the tin. Big data is a lot of data. Where does that data come from? Well, it comes from a variety of sources, and it encompasses many areas and technologies, and I'll be drilling into those in just a little bit. Big data itself as a concept has been around since really the advent of data storage. It just means a lot of data, whether that data is personal, whether it's to do with credit card information, people's names, ages, addresses, and so on, banking information. All of that is a large amount of data, and the problem of late has become more visual as more people have opened more bank accounts, for example, as more sources of data have become online and are throwing out information. How to manage that data, how to manage that information, and how to use that information for the benefits of the business has come to the fore. And there are lots of related technologies around that. You may have heard terms like data visualization, data lakes, and so on. And I'll be trying to cover as many of those as possible as well. The data itself is stored as a related set of information in a database. It doesn't matter what kind of database or where physically that database is, but it is stored in a data repository or a number of data repositories, and then application software makes links between those pieces of data. But I guess the most important thing that's happened with big data is the way in which the data is gathered, stored, manipulated, and visualized. So let's just go through those real quick. How that data is gathered. All of you have used an ATM machine. All of you have used debit cards or credit cards to draw money out and make transactions. That generates data. Or some of you may have smartwatches which measure your heartbeat, how many steps you're taking. The smarter ones measure your blood pressure and so on as well. And all that data can be stored on your phone and uploaded into an application in the cloud to measure how your health program is progressing. All of these things are gathering data. Everything that we do nowadays, right down to viewing a video on YouTube, is generating a data packet which can then be stored, manipulated, and interrogated as required. So the sources of data have increased hugely, and I think there's a statistic that went out a while back that 98% of all the data on the internet was generated in the last 5 years, predominantly from social media. So that's how the data is gathered. Not all that data is gathered and held somewhere, and it's held and stored on databases. Now, the fundamental shift here has been how that data is stored in the database. Sometimes the data is stored on a classic spinning hard disk. Other times, for faster access, it's stored on something called an SSD, a solid state device hard disk, which many laptops have now. In addition to that, there is a shift from that data being stored in or persisted, which is the correct term to use, on some kind of storage device. It has now also gone into being stored purely in memory, so in random access memory. And these are called IMDBs, in-memory database servers. In-memory database servers are utilized when speed is of the essence. So you don't have to wait for a SSD or a spinning disk for the data to be pulled out or extracted from those. It's sitting in memory already, and that makes access to that, well, it does two things. It makes access a lot faster, and the data itself is, because it's being held in memory, is much more accessible by applications. That data, once pulled from there, has to be manipulated. Now, there used to be a term, and it's still in use today, and the technology is still widely used today, something called ETL, which is extract, transform, and load. So what is happening is that data is being pulled out from these various data repositories into a central location, whether it's an IMDb or whether it's another database or into a spreadsheet, and it's being manipulated and interrogated. And for example, it could be something like the age, anyone between the age of 21 and 35 who walked into a department store. Okay, and by virtue of their mobile phone being Wi-Fi enabled, the store's in-house Wi-Fi system detects they've entered the store, records that information, and can even record their journey through the store. So that you can track down, depending on the granularity of the data, you can get very precise information. I'll come back and talk about that in a minute as well. And then the other big shift is how that data is visualized. And we have seen in recent years the emergence of several technologies and applications that allow you to visualize that data. Human beings are visual animals. We like to look at pictures as opposed to read words because it helps us interpret the information in a more succinct fashion and helps us, more importantly, take decisions on that information. So the whole visualization, data visualization industry with tools like TIBCO, Spotfire, ClickTech has blossomed. The other things that have changed, the speed at which it is gathered and processed, that's increased exponentially. So, for example, there's a lot of talk now about smart cars and self-driving cars. Adaptive cruise control has been around in cars for quite a few years. So that data, all of that, it's gathering information and being transmitted via the wide area network to some central repository, and it can be used to track the journey of a truck, for example, that's carrying goods. The sources from which it can be collected, that's coming onto IoT a little bit. So it's not just computer transactions being recorded in the cloud. It is now somebody walking down the street with their phone telling a back-end application that they are where they are. There are other new technologies emerging where smart signage on the sides of bus shelters. There's a company called Event Moments, where as you approach the sign, it senses who you are from a camera, uses facial recognition software to recognize you, and then brings up an advert which is very specific to your interests. And this, sorry, not Event Moments, Offer Moments is the name of the company that I was specifically referring to there. The tools and platforms that are available to collect, manage, and manipulate it. So there are a lot of ways you can gather data now, and there are a lot of ways you can visualize, as I said earlier, and bigger, faster, cheaper storage and memory. The other paradigm shift has been normally this data would be housed within a data center that is in a building, in an organization's building. That data is increasingly now moving to the cloud. So cloud storage and the access to that cloud storage from anywhere, at any time, from any device, in a secure and authorized manner, has, I mean, that industry and that sector has also grown exponentially over the last few years. So coming on to this next buzzword, IoT, the Internet of Things. IoT as a technology has been around for I would say, almost 20 years, actually. And the ability to, for example, track a vehicle that's traveling down a road and see its journey and communicate with that vehicle to get information about, if it's a cooling truck, for example, where they've got refrigerated items in the back, that information has been available and being able to be gathered for quite some time. Even using primitive technology such as GPRS, sorry, not GPRS, but, oh yes, sorry, GPRS, not GSM. GPRS till 2.5G, as it was called. That technology has been able to do that. But those, according to Moore's laws, you all know compute power doubling every 2 years. The whole industry and the ability to gather information through sensors, through readers, through TV cameras, CCTV cameras, and so on, that has come along a very long way. So the reason, the applications of IoT, you could see them in location-based services, locationing applications, locating items, and tracking those items. And the application industry, you see shipping, vehicles, navigation, are all places where IoT is used. Measuring and monitoring, I mentioned refrigeration trucks. At a more management level, you can talk about network routers becoming smarter and giving more relevant and timely information to network management tool applications, hubs, smartwatches, sensors. All of these things are becoming more and more prevalent, and therefore they need to be attached to the internet. That makes it an IoT device, and it's pushing out data to a central application or repository. And the last example I've got up there is recording and visual and audio things. So CCTV, surveillance, smart cities, that's another hot term where traffic control, crowd control, the ability to respond to emergencies and emergency situations and making that response time shorter and more relevant to the type of emergency that it is. All of these things have IoT technology at their core and then are enabled by bigger applications that manage the resources needed in order to address that particular requirement. So that's a quick touch on IoT. IoT is actually a subject in its own right, and we are planning to do an IoT-specific webinar, so do watch out for that, and we'll be announcing it soon. So coming back to big data. Big data, or large amounts of data, are generated, as I said, from all sorts of services. It ranges from aircraft engines, financial services, to putting RFID tags in mice. And all of these things are, as I said, generating large amounts of data. I want to now talk about a specific example or a case study which I thought sort of brings the whole picture of IoT and big data together in one place, because sometimes you could be forgiven for thinking it's technology for technology's sake and people are coming up with really cool applications and cool devices and so on, but this is a real example of how big data has been used. And it's from a study done in the States. Sepsis, which is rather a nasty infection that can be contracted in hospitals, kills 15 to 20 million people in hospital in the US each year. It's difficult to diagnose because sepsis presents as other conditions. So in order to diagnose sepsis, you have to do it in a timely manner, so you have to spot it early, and you have to use the right indicators or signals, to use the medical term, to understand whether this is sepsis or indeed something else. And the antibiotics, as I said just a moment ago, they have to be administered quickly in order to cure the sepsis. Doctors are typically trained to look at 20 different variables, and therein lies the problem. Because those variables are presented to the doctor in a variety of different ways. There are sensors that are attached to the patient, blood pressure, heart monitors, breathing, oxygen levels, pulse, things like that are attached to monitors. So that information is coming from there. There are handwritten notes that the doctor has to pull together, and other doctors may have seen that same patient and have a different lens of looking at that patient for different conditions. So they've got to gather all these disparate pieces of information together and all these variables together to recognize sepsis. So it becomes quite a challenge to do that in a timely fashion. A company called Clinical Vigilance, a system called Clinical Vigilance from Amara, focused on sepsis. So what they did, they taught the system using millions of patient records about patients who came down with sepsis, and they looked at 100 different variables, not just 20, gathered from bedside monitors, doctors' notes, and so on. Developers saw that it was necessary to look for signals in the data. So what it did, it looked at the signals in the data and then matched the signals in that data to the outcomes that the patient was experiencing and whether those patients went on to develop sepsis. And the cases that they did, they were able to recognize specific signals that were presented earlier on in the diagnostic journey for that patient. So they used a predictive model. It's not just one signal or one symptom, but a variety that vary across patients. That's another complicating factor. And now clinical vigilance can alert that patient is likely to develop sepsis with 99% accuracy. So it's a fantastic success story. The IoT piece, the data from the IoT monitor, from the patient monitors were fed into a database, as were the patient's notes and so on. And then Amara was taught how to spot sepsis from those millions of patient records. As a consequence, hospital stays are shortened due to earlier detection, because if a patient would undergo an operation, they would then, if they were to go on and develop sepsis, that would prolong the hospital stay. So hospital beds were being taken up by patients who could have left the hospital earlier and made room for other patients to come in. So that was a really quick example about how big data and IoT work together to give a really good outcome for a medical condition. And the thing to think about now is, what about your big data project? Well, first of all, you've got to understand what big data is, and I hope we've shed some light on that. And specifically, as it comes down to a lot of these kinds of projects, there's a problem that's driving the initiative. And you need to be very clear on what that problem is and what the ramifications of that problem are on your business. If your business is dependent on a large amount of data being able to be analyzed, and so you can take timely decisions on that data for your business, then a big data project is going to be on your radar at some point. So you need to understand a couple of things. You need to understand the problem you're trying to solve and the outcome that you require. You need to understand the nature of the data in terms of volume, structure, timeframes, where that data is coming from, whether it's coming in a timely fashion, and whether that time, there's a third dimension here where data coming in late could skew decisions that you're taking on the assumption that data is actually arriving in a timely fashion. So again, it comes into IoT comes into play there, and the velocity at which that data is gathered and interpreted. How are you going to visualize that data? How are you going to present it? What are going to be the clues and the things and the indicators that you're going to need to look for in order to take accurate decisions for the business? And who or what is going to take decisions on that data? And I say what because, for example, in one area of big data, of the area of foreign exchange, what's increasingly happening is decisions are being taken by computer on executing trades. And the application that's picking up all various data on the internet, from the internet, and other sources, information sources, needs to interpret the information. But the decisions finally whether to make a trade or not, based on various commercial information and other information that's coming in, will be taken by a computer. So that's why I said what there and not just who. When should you? Well, maybe it's a little early to worry, but there are some things you need to think about before you embark on your big data project that may or may not involve IoT. The first danger signal is when your inability to scale becomes a hindrance. And this kind of becomes more prevalent if the data that you're hosting is either in-house or even in the cloud, because you need to be able to have, depending on the type of data, depending on the type of application, you need to have a fair degree of elasticity and scalability on the back end. So you need to be able to add more hard disk, add more storage, add more compute power quickly and easily in order to be able to scale to the business requirements that you have as you're traveling on your big data journey. And all of those things come also play into data acquisition capability. So how is the way in which you're acquiring the data, how could that be improved? A lot of this is down to sometimes a spreadsheet being thrown into an application, and that application is interpreting the data on the spreadsheet. But maybe that application needs direct access to that spreadsheet or that database in memory so that a more timely decision can be taken. So the acquisition of that data, both at the first phase where it's being acquired, physically acquired, whatever that data is, and then when that data is being put into the, if you like, a decision-making box, which is your application and your visualization tool. And when the outcome is not what you wanted. So if you are wanting a specific type of outcome, so for example, you want to accelerate your, one recent example, one of our customers is a manufacturing company where they needed to implement, or they had implemented JIT, just-in-time manufacturing, and they needed to know in advance when they need to acquire certain raw materials for part of the manufacturing process that they have, that acquisition of raw materials, if it was just made as required, they wouldn't be taking advantage of market rates and market conditions for those raw materials. So that was a weighting factor in the overall decision. And therefore, the outcome that they wanted, which was a faster, more efficient and cheaper manufacturing process, was not being achieved, and they needed to tune the way in which they were processing and interpreting the data that was coming in. So those are some of the areas to look out for, and that was a very brief journey along the big data and IoT technology routes. If you have any questions, I'll be glad to take them. Okay, and we've had one question coming from Thomas. What's first, IoT strategy or big data strategy? I think what's first is, as I said earlier, you need to think about the problem you're trying to solve. Okay, if the data you're trying to acquire is out there and needs to be picked up through sensors, for example, then that's your first step in terms of an overall solution architecture. And then once that data is in to the digital world, how you then interpret it and into a big data repository or whatever, that's when that question sort of comes to the fore, really. But it really does depend on the application you're trying to run. We've had another question coming from Angela. What is a data lake? Okay. Again, a new and fashionable term. A data lake is basically a large repository of data from disparate sources that is being managed by an overarching tool. I mean, you hear terms like Hadoop and various other methodologies, tools, and technologies. But essentially, a data lake is a data repository that is tuned to a specific application or set of applications to achieve a desired outcome. That's sort of the industry definition, if you like. But essentially, it is a big data repository with a specific purpose and format for the application for which that data is being gathered. And one more question from Sanjeev. Hosting compute capacity. Yeah, that's a good question. Okay. Sorry, he's still typing. What is the host? Oh, no, delete. How do you measure hosting compute capacity? Okay. Simple answer to that is I don't have the first clue. You don't know until you hit a ceiling. You can estimate these things. There are tools out there that create a dummy environment or a sandbox environment, as it's called, and you can work out in a bit of a clinical environment what your compute needs may be. But I would caveat that by saying that if you have an in-house server, it's not as easy as you may think to get that server beefed up to handle the compute capacity required. I mean, you're asking specifically about compute capacity. So you need to be able to add cores and processors and RAM with the two kind of go together quite easily. And in the cloud, that becomes easier. And certainly with JAR, we have the ability to do that very quickly. In fact, customers can do it for themselves through our front-end portal. Any other questions? No, that's it. Okay, great. Well, thank you very much for your time. I want to remind you that we do have a briefing on GDPR coming up, and please contact my colleague Catherine Woolett regarding that. That's in May. And we have these series of webinars. We've also got a lot of content on our website, jar.net. Please visit that and download the information as required. And my contact details are up there as well. I look forward to hearing from you, and enjoy the rest of your day.